Hello. This video will be on the packet Understanding Decimals. So let's go and see what we're going to learn today. Go to here. This is from pages 62 to 72. And after this video and when you complete this packet, you should be able to identify the place values of decimal digits, write a decimal in words when given the number or in numbers when given the words. Should be able to understand when to get rid of unnecessary zeros in the decimal, how to change decimals into fractions, how to change fractions into decimals, how to order and compare decimals, and finally how to round decimals. So let's get started. We're going to go to page 62 for our start. Let me pull that up for us. Okay, here's page 62. And the first thing about decimals to understand is the place value. I'm going to circle that. So right here is the place value of decimals. So for example, if I were to put a number right here, this is the tenths place. And I would say, and then here's the decimal in case you can't see that little dot there, that's the decimal. I would say that is 1/10. If I were to put another number there, like let's say 2, that would be 12 hundredths. Why would it be hundredths? Because now I have ended in the place value of the hundredths. If I were to put another number there, let's say a 3, now I would have 123. Can you go up to the place value? Yes, it would be thousands, so 123,000. If I were to put another number there, let's say a 4, now I would have 1,234 10,000ths. So that would be this one here. So I've ended in the 10,000 spot, so my label would be 10,000ths. Put another number there. Now I have 12,345 hundred-thousandths, because now I've landed in the 100,000 spot. So basically you're going to read your number as if it wasn't a decimal, 12,345, and then you're going to add a label to it depending on where you end up, which place value you end up in. And so it would be 12,345 hundred-thousandths. Put one more number there. I have to get rid of my comma here now. So if it helps to put the comma in there, just to see what it would be. You read the number first, 123,456, and then follow it up, millions. So 123,456 millions. If I were to add a number to this side of the decimal, now I'm going to say and when I read the decimal. So the decimal word would be and when I'm reading it. So this would be 3 and 123,456 millions. So let's give some of those a try here. I'm going to clear these. And we're going to scroll down now to page 63. Let's look at the first row. It says for each number, underline the digit that is in the place named. So I'm going to circle this. We're going to do this one. And I'd like to do this one here. So let's take a look at those. If you have your packet with you, you can get it out and do these together. So the tenths place, we want to find the number in the tenths place. Well, tenths is the first number to the right of the decimal. So the 3 is in the tenths place. The 5 is in the tenths place. You got it. The 1 is in the tenths place. And finally, the 6 is in the tenths place. In the third row, we want to underline the number that's in the hundredths place. So it goes tenths, hundredths. So it's the second number past the decimal. So 6, 7, 3, and 5. What if I gave you 3.24762? Which number is in the 10,000ths place? Well, we have tenths, hundreds, thousands, 10,000. So in this case, it would be the 6 would be in the 10,000s place. Okay. What if I wanted the number that was in the 100,000s place? Then it would be tens, hundreds, thousands, 10,000s, 100,000s. It would be the 2 over there. Okay. Okay, let's go and do a few more. Let's look at row 5 and row 7. Scroll down here a little bit. Okay, row 5. We want to find the number in the thousands place. So goes tens, hundreds, thousands, so it would be the 4. Tens, hundreds, thousands would be the 9. Tens, hundreds, thousands, it would be the 1. So it's the number 3 places from the decimal. Tens, hundreds, thousands, it would be the 3. Okay. And in row 7, circle this one down here. Which of the following tells the value of the digit 9 in the number 2.936? So they want to know what is the value of it. So the 9 is in which place value? It's in the tenths place. So we would circle 9 tenths. Okay. Let's go on to page 64 and take a look at how to read decimals. So you can look at some of that information on your own. Let's look at problem number 1. For each problems 1 through 6, fill in the blanks with the correct decimal name. So we have to look and see what place value we're in. The 8 is in what place? Yes, the 10th. So our answer will be 8 tenths. Correct. Number 4. Let's do the second one. So let's do circle here. Let's do this one right here. So that would be, it's going to be 6 something, right? Well, let's count. Tens, hundreds, thousands, 10,000. So it'd be 6, 10, put a dash there, thousands. And it's not thousands with an S, it's thousands with the THS, 10,000. If it was 10,000s, then it would be to the left of the decimal. Okay, and we could try number 10. So let's clear. Scroll up. Now, for problems 7 through 11, write each decimal or mixed number in words. Now you're doing the other way. So before you were writing the number in words, now you're writing, well, you're still writing in words, but you got to write the whole thing, I guess. So let's do number 10, number 1. So this number here, better circle it so you can see it clearly. What is that number written in words? Well, tens, hundreds, thousands. So it's 9 thousands. 9 thousands. Okay. Number 11, let's do the second one. Over here. Okay, how would you write that one in words? Well, that would be 10 and, right, the decimal, you say and. Then you read the number, 402, so 402, what place value does it end in? Thousands, right, thousands. So 10 and 402 thousands. Okay. All right. We're going to move on to page 65. At any time I'm going too fast, you can always pause the video. Feel free to do that whenever you need to. Okay, now we're going to write the decimal from the words into a number. So let's look at number 2 right here. And if you want to do it ahead of me and then pause the video and then see if you got it right, you can do that. 2, number 6, and number 8. I think we can just fit number 8 here on the screen right there. So how would I write 63 hundredths? Well, I would write 0.63. Or you could even put a 0 if you wanted to, 0.63. Either way, it's the same number. So 0.63. How about number 6? 1 and 500. I see the word and in there, so I know I'm going to have a number before the decimal, right? 1 and, that's my decimal, 500. So I have to put a 0 and then a 5 for 500. So 1 and 500. And then number 8, 304 thousandths. So that would be 304 thousandths and then a decimal to the front of it there. So 304 thousandths. Okay, so you can practice that. Let's try page 66. Clear this and move down a little bit here to page 66. So with decimals, there's times when you can get rid of unnecessary zeros. That is if the 0 is before the number or after the number, but you can't get rid of zeros in between the decimal or between numbers. So let's see how that looks as an example. So number 1 and number 5. Let me just scroll up just a little bit. So we're going to do number 1 and we're going to do number 5. So which zeros can we get rid of in the number 5.0060? Well, let me just put a little space here for a moment so that we can write it out. So if I was going to write this number, I'll get the right color. And if I were to write 5.0060, I can get rid of which zeros? Yeah, I can get rid of the 0 on the end, right? Because it's not sandwiched in between two numbers. These zeros I have to keep, the other two, because they're between a decimal or a number, right? They happen to be between the decimal here and the number 6. So they have to stay. So that would give us an answer of letter C here, 5.006. Let's look at number 5. I'll write the number out so it's bigger. We have 0.106. So what zeros can I get rid of? Well, anything before, I could get rid of this one if I wanted to. I could get rid of this one if I wanted to. And could I get rid of this one here? No, because it's in between two numbers. But the one on the end I could also get rid of. So which answer choice fits 0.106? Yes, letter A right here, 0.106. So getting rid of unnecessary zeros will help you, especially when you get into multiplying with decimals. Okay, let's move on now to page, this would be 67. Let's look at how we change decimals to fractions. So this can be a little bit time consuming, especially because our packet is telling us to reduce the fractions. So we always have to reduce to lowest terms. So let's look at number, which one did I want to do on this page? Number 1 here. I want to do this one. I want to do, let's see, this one here is a good one to do. I'd like to do some more farther down. So let's take a look at these two first. Put a little bit of white space in between here so that we don't have extra stuff here that we don't need to look at right now. And okay, so how would I make this number into a fraction? Well, I read the number as if I were writing it in words. So it's tenths, hundredths. So it's 8 hundredths, right? Now, that's how I would write it, but I have to reduce it. So if I have to reduce an 8 and 100, I know for sure that I can divide the top and the bottom by 2. I can probably divide it by 4, but in case I didn't see that right away, I'm just going to go with 2 so I can show you if you have to do it again, you can do that. So 8 divided by 2 is 4. Remember, you have to divide the top and the bottom by the same number. So 100 divided by 2 is going to be, 50. And then notice how I could also divide by 2 again. So I could have divided by 4 originally. But let's do it again. Divide by 2 again. And now I will get 4 divided by 2 is 2. And 50 divided by 2 is 25. So now I have an even number on top and an odd number on the bottom. So, and 3 will not divide into either one of those numbers. So that is as low as I can go with that fraction. So 8/100ths can be reduced to 2/25ths. Okay, let's take a look at the next one next to us here. We have how many decimal spaces past the zero? Past the decimal. How many spaces past the decimal? We have 1, 2, 3, 4. So we have tenths, we have hundredths, we have thousands, we have 10,000s. So our bottom number is going to be 10,000. It's a big number. 10,000. Like that. And the top number is going to be 48. So 48 10,000s. And that's how you would read that number as well. But we're not going to leave it like that. We have to reduce it. So I know that I can reduce by at least 8. So let's see. I think I'm pretty sure I can do 8. So if I don't know that for sure, I'm going to change colors here just so I can see it a little differently. I'm going to divide 10,000 by 8 and see if I get an even number here. Remember, you're not going to be able to use a calculator on the test, so you're going to want to be able to do long division to get there. So let's see if 8 will divide evenly into 10,000. 8 goes into 10 one time. One there. 10 minus 8 is 2. Let's see if this will work out. Bring down my 0. 8 goes into 20 twice. 2 times 8 is 16. Yes, this will work. I can see that already. 20 minus 16 is 4. And then I'm going to bring down another 0. How many 8s in 40? Exactly 5. 5 times 8 is 40. I subtract 40 from 40. And I get 0, but I have to bring down one more 0. And how many 8s in 0? Well, 0. So we know that 10,000 will divide by 4 and become 1,250. So let's switch that over. 1,250. And now we have to divide 8. Oh, I divided by 8. So 10,000 divided by 8 was 1,250. Now I divide 48 by 8. I just want to make sure you know I divided by 8 here. So divided by 8. And on the top, we divide by the same number, divided by 8. How many 8s go into 48? The answer is 6 times 8 is 48. I am still not in my lowest terms, am I? Because I know that I have an even on top and I have an even on the bottom. So I know that at least 2 more will divide into there. So let's divide by 2 more. So this will be a little bit time consuming on this page as you have to reduce all these fractions. So now 6 divided by 2, I'm going to run out of room here, is 3. And 1250 divided by 2, well, I'm going to have to do long division, so let's bring our purple back here. So we have 1, 2, 5, 0, and we're going to divide by 2. You might have heard my dog in the background there because I'm recording this from home, so he barks here and there. So 2 goes into 12 6 times. That's a bad 6, but that's supposed to be a 6. 2 times 6 is 12. I bring that down. I subtract. I get 0, and I bring down my 5. 2 goes into 5 twice. 2 times 2 is 4. 5 from 4 is 1. Bring down the last 0, which is 10. 2 goes into 10 5 times. So 625. So let's write that. So 3 over 625. And now we have to decide, will 3 divide into 625? Well, we can add the digits, 6, 7, 8, 9, 10, 11, 12, 13. 13 won't divide by 3, so that is as low as we can go. And we'll circle that answer. So the initial number was 48 10,000s. We'll reduce down to 3 over 625. Okay. All right. I'm going to clear my drawings. Let's go on and do number, I believe there's a few down here. So let's try number 6. And let's try the first one right here. And the third one over here. Let me get some white space for us. Okay, what is the first number? How would you read that number in words? Well, you would say 16 and, so 16 is your whole number part. Okay, what do we got here? We got 4 something. 4 on top. What's the bottom number? Tenths, hundreds, thousands, 10,000s, 100,000. So 4 over 100,000. Right, try to write that here. Now I can reduce that. So I can divide 100,000 by 4, right? So if I don't know what that is, I could do the long division. So let's do that. But it should come out to be 25,000. So 4 goes into 10 twice. 2 times 4 is 8. 10 minus 8 is 2. Bring down the 0. 4 goes into 25 times. 4 times 5 will be 20. 20 minus 20 will be 0. And then I just have to bring down all those other zeros. So all of these up here will be zeros right up here. So yes, 25,000. Just wanted to check that out for myself. Okay, so if I divide the top and the bottom by 4, divided by 4, top and bottom, I get an answer of, let me just clear this, oops, cleared a whole bunch of stuff there. Get rid of that. We end up with an answer of 1 over 25,000. So the full answer is 16 and 1 over 25,000. Because don't forget we got that whole number 16 waiting over there. So the 16 would also come over here as well. So 16 and 1 over 25,000. I put my comma in the wrong place here. Right here. Okay. So far, so good. This is getting to be the harder stuff. Okay, the next part then, the next one we want to do is this 3 and then all these zeros and an 8. So let's take a look at that one. I'm just going to clear all my drawings on this side so I can make a little white space again. And a little white space there, a little white space here, and there. Okay, so now what is that number? Well, we have a whole number 3. And what is the number that we're going to put here? So the fraction part. Well, we're going to put 8 on top. I can see that. And let's count. Tenths, hundreds, thousands, 10,000s, 100,000s, millions. So 8 over 1 million. So how do we write 1 million? Like this, right? Millions, 8 millions. 0, 0, 0. Okay, so now we have to reduce that, right? So I believe we can put 8 into there again. So let's do that. Let's try putting in 8 and dividing that. You can already see what it's going to be, but let's just show the example. Millions. We write it here, comma, another comma there. Here. How many 8s go into 10? Well, it's going to be your 2 again. 10 from 8 is 2. 2. Yep. bring down the 0. How many 8s and 20? Oops, that should have been a 1. This is 1, not 2. Hold on a minute. So right here, that should be a 1. I lost my white space again. Okay, and then we get 20. So how many 8s into 20? 2. 2 times 8 is 16. 16 minus 20, or 20 minus 16 is 4. And I lost track of which 0 I'm on. This one, I'm on this 0. That's why it's always good to put these little lines so you know which 0 you're on. How many 8s in 40? 5 times 8 is 40, and then I'll end up with just zeros left on the top. So just like in our previous problem, so now we get 125,000. So I divided 8 into the top and into the bottom. Put the little numbers there. Divided by 8, and divide by the same number on top and bottom. My mouse isn't cooperating real well today as far as writing numbers. So 8 divided by 8 is going to be 1. 1 million divided by 8 is 125,000. And then, of course, we've got the 3 tagging along there as the whole number. So the official answer is 3. Put the 3 over here. 3 and 1 over 125,000. So let's circle that. So you see the full answer right there. And that is the answer for this problem right there. Okay, so you got a little bit of work cut out for you on those pages. Let's clear our drawings and let's move on a little bit and do the opposite now. We're going to change fractions to decimals. So this too is a little bit of work. Let's take a look at number 1. Some of these you might just know off the top of your head, but in case you don't, here's how we figure these out. So again, it's a lot of division. So when you have 1/4, it's the same as putting the 1 on the inside and the 4 on the outside. So you say how many 4s will go into 1? None, right? So you put a decimal and a 0. Don't forget to put the decimal up here right away. How many 4s go into 10? 2. 2 times 4 is 8. 10 minus 8 is 2. And then I can keep adding zeros, right? Because it doesn't change my number at all. So I'm going to bring down another 0. Remember when we were doing the unnecessary zeros? You can just keep adding zeros. You're not really changing the number at all. How many 4s go into 20? 5. 4 times 5 is 20. And 4 times 5 is 20. I subtract. I get 0. No remainder left. So 1/4 is the same as 0.25. And that one you might have known anyways because there's 4 quarters and $1. But some of these you're not going to know. They're not common ones that you're going to just know off the top of your head. So, all right, let's do number 4. Let's go right over here. Or this one, 1/3. Let's do 1/3. I can circle it right here. So again, we're going to do the same thing. I'll change colors here. Let's do 1 on the inside and 3 on the outside. So the top number is always on the inside. So how many 3s go into 1? None. So we put a decimal and a 0. And we put the decimal place up here as well right away. So how many 3s go into 10? 3. 3 times 3 is 9. 10 minus 9 is 1. I'm going to add another 0. I'm going to bring it down. Okay, I've got 10 again. How many 3s go into 10? Well, 3, right? 3 times 3 is 9. If I subtract, 10 minus 9 is going to give me 1. I can add another 0. And notice I'm going to get 10 again. So I'm going to put 3 into there again and again and again and again. So notice how it's going to be a repeat. So you can just write the answer then as 0.3 with a line over the 3, meaning that the 3 repeats forever and ever and ever. So that's one way to write it. Another way to write it is if we were to continue our division and say, okay, how many 3s go into 10? We would say we've already done 10. We've already done 10 minus 9 is 1, right? So then if we were not to add that extra 0, let's get rid of that, we would then have a 1 as a remainder, right? So we could take that 1 as a remainder and write it up here, 1, and then put 3 as the bottom number, because there's the 3 over here. So that 3 becomes the bottom number, and the remainder becomes the top number right here. So you could write it as 0.3 with a line over the 3, or you could write it as 0.333 and 1/3 if you wanted to do that. Like that. So both of those mean the same thing. Okay, I'm going to clear that. Let's take a look at row 4. Let's go up to row 4 here and do number 3. So circle that one. Let's try 1/12. Okay, and I'm going to make some white space because I think we're going to need it here. Right here. Let's put some over here too, in case we need it over there. Okay, so how would I make 1/12 into a decimal? Let's put the 1 on the inside and the 12 on the outside, because the 1 is on the top, numerator always on the inside of the division sign here. How many 12s go into 1? None. So I put a 0.0. This one's a good one to do because you have to do a little something extra. How many 12s go into 10? Well, 0, right? So we have to put the 0 in there this time. 12 times 0 is 0. And then we subtract. 10 minus 0 is 10. And I'm going to add my 0. And I'm going to bring it down. So how many 12s go into 100? I believe it's 8, because 12 times 8 is 16, carry the 1, 96, and that's as close as we're going to get. So 100 minus 96 is 4. We're going to keep going. We haven't gotten to anything that repeats yet, and we haven't gotten to a 0 remainder. So we're going to bring down another 0. How many 12s go into 40? 3. Right? 3 times 12 is 36. So 40 minus 36 is going to be 4. And now you can notice what's going to start happening. We brought down another 0. We would now get 40 again. So we're going to end up with a 3 repeating. So the answer would be 0.083 with a line over just the 3, because just the 3 is going to start repeating. So that's one way of doing it. Another way of doing it would be to have a fractional portion left. But if I were to do that, let's see, I would end up with a remainder of 4. So I would do 0.083, and then instead of bringing down the 0, I would have a remainder of 4 on top and 12 on the bottom. So I would end up saying it is 0.083, and then 4 12s would reduce down to 1/3. Right? 4 goes into 12. So you could write it as either, let me just move it out of here once. You could write it as either 0.083 with a line over the 3, or you could write it as 0.083 and 1/3. So either one of those would be correctly written. Okay, let's clear that. Let's move on then to page 70. This one is just calculator use. Same thing, you're just using your calculator. I'm not going to go over this page. Comparing decimals, we will start with that one. So that's page 70. Let's take a look at number 1. We're going to compare. Let me just get some space here. Right here. We're going to compare the first one. So we have the number 0.04, and this is how you're going to do it. You can put the 0 in front if you want. 0.04 And we're going to line up our dots with 0.008. And we're going to say which one is larger. So we're going to look first at the first column. And I'm going to change colors here. First column here, they're both zeros. So we have to go to the next column. They're also both zeros. So we have to go to the next column. And we say, okay, which one of those numbers is bigger or smaller? Well, the 4 obviously is bigger than the 0, right? So if we were to say which number is bigger, we would then say 0.04 is bigger. So that's how you compare with decimals. You have to line your dots up and then go column by column. So let's see how that works if we're ordering numbers. Clear this. So for ordering numbers, let's take a look at number 7. Let's do the first one in the row here. Move it up a little bit. Right here, they want us to put it in order from smallest to largest, I believe. Let's go up and take a look at that. Smallest to largest, yes. So, make some white space again. So when we want to do it from smallest to largest, we want to again line up our decimals. I'm going to leave the 0 off the left side of the decimal. They're all zeros. So if it wasn't all zeros, then I would have to include it. But so 0.0072. That's a bad 2. 0.07. Let me fix my 2 so it looks more like a 2 here. That's better. 0.07, 0.027. I'm trying to line these up. And then we have 0.02. Okay, we want to go from smallest to largest. So we're going to go column by column. We're going to start with the first column. Which one is smallest? They're all the same. So we have to go to the next column. Which one is smallest? Yes, the 0, right? So we've got our first answer. The smallest number is going to be 0.0072. Okay, and cross that one off. We're done with it. Looking at the row, which one, or the column, which one is the next smallest? Well, the 2 2s, right? So we're going to have to go to the next column and compare just between these two numbers. We're going to have to compare the 7. And what does the empty space mean? Well, that means 0, right? So we're comparing a 7 with a 0. So which one's smaller? The bottom one. So that's the next smallest one. So that would be 0.02. And then I can cross that one off. And then the next smallest would be 0.027. And finally, the last smallest, or the biggest, is 0.07. So that's how you would order decimals. Line them up, and then go column by column. And the last one I want to do is page 72, rounding decimals. Let's go right on to do number 1. Round each decimal to the nearest place value given. So they want us to round to the 10th place. So the 10th place is the 2. And we look at the number next to the 2, to the right of the 2. If it is 5 or more, we're going to round up. We're going to round the 2 up. So in our case, it's a 9, so we're going to round our 2 up to 3. So 4.3. One more in the 10th place. That's a 6. We look next door. It's a 3, so that's less than 5, right? So we're going to keep it a 6. So it's going to be a 0.6. It's not going to round up. Okay. Let's try row 3, the thousandths place right here. So tenths, hundreds, thousandths. This time we're going to round to the 6. So look at the person to the right, or I mean the number to the right. If it's 5 or more, we round up. It is not. It's a 1. So we're going to keep all the numbers until we get to the 6, and then we have to decide what to do with it. 23.48, and we're going to keep the 6 a 6 because it's got a 1 next to it. So we're going to do this, 23.486. Okay, so that's how you use rounding. And I believe that's the end of the packet for the most part. So let's go back to our, where is it? Go back to our understanding decimals here and see if we understand the things that were the objectives today. So can we identify the place value of decimals digits? Yes. Can we write a decimal in words or write a number from words? Yes, we can. Can we understand when to get rid of unnecessary zeros and decimals? Yes. And can we change decimals to fractions? That was the one where we had to keep reducing. Yes. Can we change fractions to decimals? Yes. That's one where we had to do a lot of dividing. Can we order and compare decimals? Yes, that's where we have to put them in order and check them column by column. And then finally, can we round decimals? So if any of these are still a little bit unclear, I would suggest going back and watching parts of the video or just practicing the packet and getting a lot of practice. So I hope you have a great day, and let me just stop my share, and then we'll see you again. Have a good day.